My name is Alison Meston, and I'm studying the Program Certificate in Climate Change Management at the School of Geosciences at Edinburgh University. I'm an Australian of Scottish descent living in Paris, so it makes sense that I'll be talking about the climate change vulnerabilities and impacts in France, and in particular the Champagne region, where that most famous of French wines comes from. This video will examine the vulnerabilities and impacts of climate change on the region, and in particular the impact on viticulture. The Champagne-Ardenne region of France is situated in the northeast of the country, is 25,600 kilometres square and has a population of around 1.3 million people. Reims is the largest city and has a population of 185,000 people. The population has been steadily declining in recent years, and the region has one of the lowest birth rates in Europe and one of the largest ageing populations. Reims boasts Haussmann-style buildings of around 5 stories, along with modern apartments, and buildings that sit alongside the UNESCO World Heritage Site of Notre Dame Cathedral and a number of late 19th century forts. The river Vesle meanders through its centre. Outside of the built-up urban areas of Champagne-Ardenne, 61.4% of the land in the region is devoted to farming, with the predominant land use being cereals, bovine farming and viticulture. There is 3,133 square kilometres of vineyards. 99% of the grape varieties planted in the region are Pinot Noir, Meunier and Chardonnay, produced to keep up with the growing demand for champagne in domestic and overseas markets. Whilst the region overall ranks 18 out of 22 in France's Department for Gross Domestic Product, wine production and its associated industries are what the region is most well known for. France's climate is temperate and divided into 4 areas. Eastern France, which contains the Champagne region, has a continental climate, which harbours cold winters and hot summers. Average summer temperatures are around 18 degrees C and 4 degrees C in winter. Whilst not near an ocean, the oceanic influence still brings regular rainfall between November and May, with a yearly average of between 550 and 700 millimetres per year. The continental influence allows for around 1,500 hours of sunlight per year, just the right amount in summer needed to ripen grapes. However, grapes are notoriously sensitive, and the northerly location means a colder climate and the potential for harsh winter conditions that can adversely affect vines, including frosts. In recent years, extreme weather events have caused problems for the region's harvest. In April 2017, Champagne was hit by extreme frosts, which damaged the new shoots on the vines that had already arrived early due to warmer and milder spring. Growers were forced to warm their vines with oil candles in order to prevent further damage. The Champagne Committee reported that all areas of Champagne were hit and projected a lower yield for the year, already on the back of 2016, which produced 20% less grapes due to spring frosts that killed flower buds and caused an outbreak of mildew on the vines. Helicopters were even used to create drafts in order to save the crops. In August 2017, extreme weather caused hailstones to blanket Reims, and earlier in the summer, storms caused major flooding in the unofficial capital of Champagne. Grape growers reported heavy damage. In 2003, most of Western Europe suffered from an extreme heat wave. Close to 15,000 people died in France, many of them elderly in built-up areas due to the temperature anomalies of more than 6 degrees for a sustained period of time. The heatwave of 2003 resulted in an early harvest of crops, with the heat and the sun causing the grapes to sweeten and ripen sooner. This graph shows harvest times for the Champagne region since 1600, where 0 is the average harvest date and -30 is 30 days sooner. You can see where the 2003 heatwave affected the harvest date. Another heatwave occurred in 2015 and caused heat stress on the vines in the region. 2011 also saw France's hottest and driest spring, which saw an 8% decrease in wheat yield. The projected climate changes in the Champagne-Ardenne region suggest a substantial summer precipitation decrease of 0.6 millimetres per day and a moderate winter increase of 0.3 millimetres per day, most over the northernmost part of France. Given the inherent climate sensitivity of grapevines, suitable zones for their cultivation are very susceptible to small changes in climate. Temperature increase under the representative concentration pathways, or RCPs, show an RCP of 2.6 with around 2.5 degrees increase for the Champagne region, but a 4-degree increase with an RCP of 6. This infographic shows the different scenarios laid out by the IPCC. Because we are looking at a regional level, we're going to concentrate on A2 and B2 scenarios and what this might mean for the projected changes in Champagne. This is a baseline picture of the grape-growing regions of France, with Champagne at the top in purple. A study by Moriondo et al. Showed that viticulture regions are confined to specific climate niches that put them at greater risk from changes in rainfall and temperature that may destabilise the equilibrium between climate, soil and variety, which could profoundly influence the production of high-quality wines. Here we see a scenario A2 on the left, showing slower economic and technological growth and higher population growth, and on the right, intermediate growth, moderate population growth, and less rapid but more diverse technological change in the B2 scenario. Future climatic change under these projections show progressively warmer and drier conditions, particularly in the southern grape-growing regions, showing that these regions could move north, changing the variety of grapes in Champagne. Climate projections in the IPCC Fifth Assessment Report for Europe overall show a marked increase in high temperature extremes, meteorological droughts, and heavy precipitation events. In Champagne, the result will be that the average harvest date will come earlier, quickening grape maturity and increasing sugar concentration, fruit flavour intensity, and lowering acidity, potentially changing the taste of the wine. On top of this, disease risks such as mildew from heavy rain events seems likely. However, the IPCC reports that even though droughts may be more frequent, advances in technology and adaptation in the water sector through the EU Water Framework and Flood Directive could mitigate vulnerabilities in the agricultural sector. The IPCC also notes that sea levels will rise and increases in extreme rainfall are projected to further increase coastal and flood river risk in Europe without any adaptive measures. This will substantially increase flood risk. This is a strong vulnerability in the Champagne region, given its many urban areas are built along the region's 650 kilometres of waterways. Under A2 and B2 scenarios, the IPCC suggests that infrastructure in Europe is vulnerable to weather events, including overheating of buildings in built-up areas. With the Champagne region's ageing population, this could be a major vulnerability to human health in the coming decades. The Notre Dame Cathedral in the centre of Reims could also be vulnerable, as buildings of cultural significance are affected by extreme weather events and, of course, are irreplaceable. The IPCC reports with high confidence that all aspects of food security are potentially affected by climate change, including food access, utilisation and price stability. This is particularly impactful for the Champagne region, where, according to Jones et al., centuries of experience in viticulture have matched varieties with environments in which they perform best, resulting in geographically distinct viticulture regions. While climate change represents an opportunity for grape-growing regions in England, the key vulnerability to the Champagne region is the loss of its appellation and terroir, which is what gives it its distinct high-end markability. To call a vintage Champagne, its grape variety must be sanctioned by the Champagne Committee, and it must be grown within the confines of the Champagne region in order to gain its appellation d'origine contrôlée. The Taittinger Champagne House recently bought land in England in recognition of projected changes to the climate in France. Therefore, one of the key transboundary impacts of climate change for the production of champagne is that current appellations could become obsolete, as regions from outside their boundaries slowly become better suited to producing champagne grapes. In its fifth assessment report, the IPCC noted that wine production in France accounted for 60% of the global total and made an important contribution to cultural identity. The report suggested that the Pinot Noir grape, one of the 3 varieties associated with Champagne, would be at risk with its traditional terroir, and that the region may need to become geographically flexible in its historical or constructed sense of culture. However, this seems unlikely given the history of the Champagne Wars of 1911 and more recently France reminding Mongolia that it was not to call its bubbly champagne. France and its appellation regime, along with key vulnerabilities such as high temperatures, extreme weather events and early harvests affecting grape sugar levels, will need to adapt and adapt quickly if its most famous wine will live up to its name of champagne.